Hello students, how are you all? All are well and fine? Okay, good. You know all, last two classes we are seeing about the chapter, we are learning about the chapter thermal physics, isn't it? So last class what are the contents we have seen? What are the contents we have read? We have read about expansion of substances and what are the substances it undergoes on expansion. Do you know? All forms of matter, that means solid, liquid and gas, all the three forms of matter it undergoes expansion. From this, in the expansion of solid, we have seen three types of expansion, isn't it? One is linear expansion, another one is superficial expansion, another one is cubical expansion, isn't it? What is called linear expansion? If the length of the object it undergoes on heating, that is called linear expansion. Superficial or aerial expansion means the expansion when heated the object will be increased by the area. Then cubical expansion means volume of the object will be increased due to heating, isn't it? So that is called cubical expansion. We have learned no. Then what about real and apparent expansion? It undergoes on expansion in liquid and solid, isn't it? Next, we are going to see fundamental laws of gases. Next, we are going to learn about fundamental laws of gases. So here three types of laws are there, connected to the relationship between pressure, volume and temperature. Okay, for that what are the three types of laws? Boyle's law, Charles' law and Avogadro's law. Okay, we can see one by one. So what is called Boyle's law? Boyle's law means when temperature is kept constant, when temperature it will be kept constant, the volume of fixed mass of a gas is inversely proportional to its pressure. So that is called Boyle's law. Okay, once again I will tell, when the temperature is kept constant, because both pressure, volume and temperature are involved in all the three laws. Okay, for that here in this Boyle's law, the temperature is kept constant, the volume of fixed mass of a gas is, that is inversely proportional to its pressure, or we can write it as PV equal to constant. Okay, so this is called Boyle's law. Okay, then we move on to Charles' law. So what is called Charles' law? Here the pressure will be kept constant. Pressure will be kept constant. The volume of the gas is directly proportional to its temperature. The volume of the gas is directly proportional to its temperature. Or we can write it as V by T equal to constant. Okay, next Avogadro's law. Here what will happen? Pressure and temperature both it will be kept constant here. The volume of the gas is proportional to the, that is directly proportional to the number of atoms of molecules present in it, or we can write it as V by N equal to constant. Okay, in Avogadro's law, both the pressure and temperature will be kept constant. Volume of the gas is directly proportional to the number of atoms of moles present in it, or V by N equal to constant. Okay, all these three laws, that means Boyle's law, Charles' law and Avogadro's law, I will explain you in the diagram basis. Okay.
So this is about Boyle's law. You know all Boyle's law. I have told the pressure of the gas is inversely proportional to the volume. When temperature it will be kept constant, isn't it? In the picture you can see, if the pressure it will be increases, then the volume it will be decreases. So this is called Boyle's law. Once again I will recall. Boyle's law, it states that the pressure of the gas that is inversely related to the volume when temperature and number of moles, that is N, are kept constant. Understand? If the pressure it will be increases, then volume it will be decreases in the Boyle's law. So this shows the Charles' law. Charles' law, it states that the volume of the gas is directly proportional to the absolute temperature, assuming that quantity of gas and pressure will be kept constant here, that is V by T equal to constant. In this picture you can notice the pressure it will be kept constant and the quantity of the gas also it will be kept constant. Volume of the gas that will be proportional to the absolute temperature. So this is called as Charles' law. Here this is the picture showing Avogadro's law. Here equal volumes of a gas, it contains same number of molecules at same temperature and pressure. So we can write it as volume of the gas by number of atoms equal to constant. Here pressure and temperature will be kept constant in Avogadro's law.
Next we will see Avogadro's number. What is called Avogadro's number? So it is the total number of atoms. Okay, it is the total number of atoms for per mole of the substance present for per mole of the substance. That is called Avogadro number. Avogadro number it can be written as Na. Okay, the symbol of Avogadro number will be a Na. Okay. Once again I recall, it is the total number of atoms for per mole of the substance. For 1 mole of the substance, it will be equal for total number of atoms. So total number of atoms for 1 mole of the substance, that is called Avogadro number. Then it is equal to the value 6.023 into 10 to the power 23 per mole of the substance. Okay, so you have to memorize the value of the Avogadro number. Okay. Next, we are going to see about gases. So gases can be classified as real gas and ideal gas. Okay. So what is called real gas? Real gas means if the molecules or atoms of the gases, okay, the molecules or any atoms of the gases, they both interact with each other. Okay, they will interact with each other with a definite amount of intermolecular or interatomic forces of attraction. Okay, they are interact with each other. The molecules or atoms of any gases, it will be interact with each other with a definite amount of intermolecular or interatomic force of attraction. Okay, so that is called real gas. Okay, then what about ideal gas? Ideal gas, you can otherwise we call it as perfect gas. Okay, here in this the atoms or molecules of a gas, they do not interact with each other. In this ideal gas, the atoms or molecules, they do not interact with each other. Actually, in practice, no gas is ideal. No gas will be ideal because the molecules of any gas, it has a certain amount of interaction among them. Okay, it has a certain amount of interactions among them. So, but what happens? But these interactions are very weaker when pressure will be low or temperature is high because of intermolecular force of attraction. Okay, once again I will recall. Actually, in practice, no gas will be ideal. Why? Means the molecules of any gas, it has a certain amount of interaction between them. Okay, for these, sometimes the interactions are weaker when pressure is low or temperature will be high because of interatomic or intermolecular force of attraction. Here, then real gas at a low pressure or high temperature, it will be termed as perfect gas. Real gas at a low pressure or high temperature, it will be termed as perfect gas. Then this ideal gas, it obeys all the 3 laws. What is called Boyle's law, Charles' law and Avogadro's law. Okay. Next, at very high temperature or low pressure, the real gas it behaves like an ideal gas. Why? Because in this condition there is no interatomic or intermolecular force of attraction. Okay. Once again we will recall. So what is called Avogadro's number? Avogadro's number, it is the total number of atoms for per mole of the substance. That is 1 mole of the substance. Then it is equal to the value range of 6.023 per mole. Okay. Then about gases, it is classified into real gas and ideal gas. Real gas means the molecules or atoms of molecules or atoms of the gases, they interact with each other. Okay. In ideal gas, they do not interact with each other. Okay. Then the molecules of any gas, it has certain amount of interactions among them. Sometimes the interactions will be weaker when the pressure will be low or temperature will high. For what reason? Because of interatomic or intermolecular force of attraction. Okay. Next, real gas at a low pressure or high temperature, it will be called as perfect gas. Okay. Then these ideal gas, it obeys all the three types of laws: Boyle's law, Charles law, and Avogadro's law. At very high temperature or low pressure, sometimes real gas behave like an ideal gas. Why? Because in this condition there is no interatomic or intermolecular force of attraction.
Here this is the differentiation between real gas and ideal gas. So a real gas, it is a gaseous compound which exists in the environment. But ideal gas, it is a hypothetical gas which does not exist in the environment. And second one is, here interatomic or intermolecular forces are done here. In ideal gas, there is no interatomic or intermolecular force of attraction. Then in real gas, the particles, it has a definite volume and mass. But in ideal gas, the particles, it does not have a definite volume and mass. The collisions are occurs between the real gas molecules and it is a non-elastic form, and the collisions between the ideal gas molecules are in the elastic form. Here the kinetic energy of real gas particles is changed with collisions, but in ideal gas the kinetic energy of ideal gas particles is kept constant. Okay, then a real gas may behave as an ideal gas at low pressure and high temperature conditions, but in ideal gas it may behave like a real gas at high pressure and low temperature conditions. So these are the main differences between real gas and ideal gas.
Next we will see ideal gas equation. Okay, just we see the derivations of ideal gas equation. You know all ideal gas, it obeys Boyle's law, Charles law, and Avogadro's law. No, for that, according to Boyle's law, what is that? PV equal to constant. For Charles law, V by T equal to constant. Avogadro's law, V by N is equal to constant. Isn't it? So all these three laws equation, after we combining all, so we get the equation PV by number of moles into temperature equal to constant. PV by NT equal to constant. Okay, these combined equations we called it as combined law of gases. We can call it as combined law of gases. Then if you consider a gas, any types of gas, okay, which it contains mu moles of it has the mu moles of the gas, then how can you write number of gas equal to mu into mu times to the Avogadro number? What is the NA called? It is the Avogadro number. So using this fifth equation, we can combine this 4 and 5. Okay, then how can we write PV by mu NA, that is Avogadro number into temperature, equal to constant. Okay, then the value of the constant we can be written as Kb, that is called as Boltzmann constant. Okay, we can write it as Boltzmann constant Kb. So the value of Boltzmann constant is 1.38 into 10 power minus 23 Kelvin power minus 1. Okay, after this, removing the constant, instead of constant we can write it as Boltzmann constant, that is Kb. Then how can we express PV by mu NA, that is Avogadro number, T equal to Kb. Okay, then we can cross multiply this equation we can written as PV equal to mu times to the Avogadro number into Boltzmann constant into temperature. Okay, here we can write it as this mu NA kV. We can get it as R. That is, R is the universal gas constant, whose value is universal gas constant, whose value is 8.31 into Joule mole power minus 1 Kelvin power minus 1. Okay, instead of using this mu NA kV, we can write it as R, that is universal gas constant. So in this we can change the equation and write it as PV equal to RT. Understand? So this ideal gas equation is otherwise called as equation of state. Equation of state, because it gives the relation between the state variables and it is used to describe the any forms of gas, any state of gases. Okay, so this is called the ideal gas equations. Once again we will recall. So you know all these Boyle's law, Avogadro's law and Charles' law comes under the ideal gas. It obeys the ideal gas. So from that we can take we have to write all these three equations. Okay. So pressure and volume is equal to constant. Here V by T equal to volume by temperature equal to constant. V by number of moles of atoms equal to constant. Isn't it? Then combining all these three equations, we can write it as PV by NT. Okay, equal to constant. Constant, it is a common word, so we write it as equal to constant. From combining these three equations, we get the fourth equation. So this equation is called as combined law of gases. Why? Because from this only we take it as and write it as combining law, so we can write it as combined. Call it as combined law of gases. Okay. Next, if you consider a gas which it contains a mu moles of a gas, then you can write it as number of atoms is equal to the mu times to the Avogadro number. Mu times to the Avogadro number. What is called NA? NA is the Avogadro number. Then using this fifth equation, fourth equation, here combined equation is there now. This should be written as PV by mu NA. PV by mu NA into T. Understand? Equal to constant. Apart from number of moles, we can write it as mu NA. Understand? Next, the value of constant can be taken as this constant. The value of constant can be taken as kV. kV is called as Boltzmann constant. Boltzmann constant means 1.38 into 10 power 23 Kelvin power minus 1. Okay. Next, how can we rewrite as PV equal to mu NAT equal to, instead of constant we are writing as Boltzmann constant kV. Then it should be rearranged and write it as PV equal to mu NA kV T. Mu times to the Avogadro number, Boltzmann constant and then temperature. Okay. Next, this mu NA and kV we can take it as R. R is nothing but it is a universal gas constant whose value is equal to 8.31 into Joule mole power minus 1 Kelvin power minus 1. Understand? Next, how can we rearrange and write this equation? PV, pressure volume equal to R into T. That is universal gas constant into temperature. Okay. This is called ideal gas equation, and this equation is also called as equation of state. Why? Because it gives the relationship between the state variables and it is used to describe the state of any forms of gases. Understand? So from this the chapter is over about thermal physics. So up to that what we have, go through all the pages and write the assignments and send it in the WhatsApp group, students. Thank you all.